Hello, everyone. Welcome. So we're going to give people time to join us. So in the meantime, I'll just show you a little video we have about the space industry in the Paris region. See you in a couple of minutes.
When I was a kid, I always dreamed about space. I loved watching the sky during the night. And I've always been fascinated by all the space explorations.
And I wanted to be an astronaut too. The space industry is really transforming quickly. And now we have much more satellites, miniaturized, and they operate in constellations. And this gives new activities and new markets for the space industry.
This is a fast-moving, dynamic market. Everyone heard about new space. It's all about making satellite business faster, cheaper, and much more accessible in terms of cost.
So TrustMe is a deep tech company in the space industry, and we provide new innovative propulsion systems for next generation satellites. We have 12 different nationalities.
Airbus is an international company. We are providing equipment for spacecraft, for satellites. I really enjoy working with people from other countries, with other backgrounds. We have exchanges, for example, with Centrale Supélec, and people come here to do their internships or their thesis.
At the Space Center, there are 4 nanosatellite missions on which we are working. There are about 80 students dispatched on all those subjects. On the mission ESIS, there is a partnership with NASA. We have the chance to work not only with French people, but more international people.
And it's very important to have this big mix between real big companies, startups, and also the research infrastructure. France is a great country to live in, and it's in the center of Europe, so it's a perfect place to be.
All right, pretty exciting video. So it's great to kick off the event with that. Welcome, everyone. My name is Melvin Pells, Corporate Innovation Manager for the US branch of Choose Paris region. I will be your host today for this tech meeting dedicated to space. So let me share this presentation. All right, so here is our agenda for today. After a short introduction, I will provide some key figures about the space industry. Then we will move on to a fireside chat with some experts about the sector. And then we will have a selection of innovative companies presenting their solution. We'll ask questions at the end of the fireside chat. We'll take questions after each of the presentations. So feel free to use the question tab, the question feature of Storm. You can actually use it to say hi or send a little message, tell us where you're from. Well, let's get into it. For those who don't know as yet, Choose Paris region is a catalyst for business and innovation. We partner with Fortune 500 corporations in order to support international companies willing to expand and set up business in the Paris region. Thanks to our presence in vibrant tech ecosystem, so you can see here San Francisco, Boston, New York, Beijing, Shanghai, and of course Paris. We are in touch with over 4,000 international companies per year. So this unique relationship with large corporations on the one hand and with Innovative, fast-growing companies, on the other hand, led us to create the Global Open Innovation Network about 4 or 5 years ago. Through this global program, we organize about 30 events a year to foster business and technology partnerships between large corporations and startups. So since the pandemic, we moved events online, which allows us to get in touch with more people, to invite more companies. So it's been pretty interesting. And well, we cover an area of technology. So you can see here AI, AR, VR, robotics, and a bunch of different industries, mobility, energy, health, you name it. And well, today we're going to talk about space. A lot is happening today in the space industry. We recently celebrated the 20th anniversary of astronauts like having presence in the International Space Station. A couple of days ago, SpaceX broke a new record by sending over 140 satellites on one single rocket. And well, yesterday, Virgin Galactic stock reached new heights. So it's very exciting, and well, people have a lot of excitement for space today. So here are some key figures I wanted to share. I'll try to go pretty quick. So first, the market size of the space economy, which is supposed to reach $2.7 trillion by 2040, from 450 billion today. So a pretty big jump. We also have here, the number of satellites that we have in orbit, 6,000 satellites. The thing is, by 2028, we'll have about 1,000 satellites launched every year. So this is about to explode. Well, to increase, and let's not use a proper vocabulary. And so the goal is to have mega constellations. So you probably have heard of Starlink, SpaceX mega constellation to bring internet to everyone. When complete, it will have about 12,000 satellites. So you can see that a lot is expected in terms of satellites in orbit. Today they have two main functions. Well, two main uses, I would say. Communication. It's about 60% of satellites, and Earth observation, which is about 27% of satellites in orbit today. I also wanted to mention this major milestone. Elon Musk really wants to send people to Mars, and is planning on sending people by 2026 on the red planet. Meanwhile, there's like a lot of other big milestones. There's, for example, NASA that's planning to go back to the moon by the end of the decade with the Artemis mission. So a lot is happening, as I mentioned earlier. So overall, we can identify three main trends. We have cheaper access to space thanks to a multitude of new players and technological breakthroughs, such as reusable launch systems. There's a lot of new commercial uses for space. So there's space tourism, Earth observation, there is space data that is being used, so a lot of things. And as I just mentioned, there's a renewed interest for space exploration. So for instance, in the next couple of weeks, 3 different missions are going to reach Mars. NASA is getting there. China is also sending a mission, and the Emirates. So it's pretty exciting. And then the two graphs on the right, just to complete what I just mentioned, in terms of Earth observation satellites, you can see that space and defense is the main use. And then public authorities represent about 18%, followed by energy, 11% for energy and monitoring of natural resources, followed by agriculture, services, and industrial uses. And then the bar chart tells us a bit more about fundraising and investments. So you can see that both that a lot of money is being poured in the space industry, and the number of deals as well as the amounts put in the industry is increasing steadily. So finally, to finish this introduction, I wanted to give you this quick overview. So this is a market map we designed based on different players we have identified in the space. It is not exhaustive. There are a lot of companies, and it doesn't include big companies such as SpaceX or Virgin Galactic, but it gives us a pretty good idea of what is happening in the space today. You can see, for example, that there are a lot of startups in the related to launch services and launch vehicles. There's also a multitude of startups working for the manufacturing of satellites, propulsion, and all the hardware related to it. And as I also mentioned, communications and Earth observation. We have a pretty dense program today, so I don't want to get too much into detail. But if you're interested or if you have questions about this, well, we will share this market map first with the audience. And then if you have questions, we're happy that you reach out and we can talk about it together. So without further ado, I'm going to invite our two first speakers for the fireside chat. So Christelle and Jerome, if you can join me on stage.
Hello.
Hello, Jerome. How are you?
I'm fine. Thanks for the introduction.
Hi, Christelle.
Hi.
So thank you for accepting my invitation and being with us today. Very excited to get your point of view on different topics. So first of all, to give some context to the audience, could you tell us more about you and about your organization, like in a minute or two? Maybe Christelle, you can start.
Okay, thank you for the flow. So I am Christelle Astorg-Lepine from CNES, and I am in charge of a program which name is Connect by CNES in the Innovation Directorate of the French Space Agency. And just to say two words of this program, we should say that besides a historic space program in the domains of science and defense, where CNES is a traditionally prime player, space can also be a key driver of economic and social and environmental development for business. And that's why we created a Connect by CNES program to support and federate a space user community in France, Europe, and around the world.
Thank you. Want to go ahead, Jerome?
Yeah, thanks for welcoming me for this chat. My name is Jerome Vila. I've been working on space projects for more than 20 years now, and rocket mainly. And 2 years ago, I founded a special unit here around Paris named ArianeWorks, and dealing with rocket technology with the backing of the French Space Agency and Ariane Group, which is the main company behind the Ariane rocket series. I use a special unit to qualify ArianeWorks because it's not a company, at least yet. It's more like an engineering or innovation platform involving different European space players that are with a mission to boost space projects that are in need for speed. And this is what we do. And right now we are pretty busy working on designing and testing a reusable rocket stage prototype for Europe. And well, with this position, I'm caught in between old space and new space, if you want. I am an old space guy because I'm not pitching a business case today. And I'm a little bit of new space also because what we're trying to achieve with ArianeWorks is to bring this agility and this speed in our projects that is so exciting with new space.
Mm-hmm. Well, thank you for the great transition, because actually I wanted to ask you about new space. You know, preparing this event, I've seen new space as a keyword being used everywhere. It's a bit like artificial intelligence with all the companies we see here in Silicon Valley. Everyone is using it for different types of applications. So I was curious to get your point of view and your definition of what is new space. So what does it mean? What does it mean for you?
Go ahead, Christelle.
Okay. So for me, new space means new players, new space domains, new usage, new funders, centrally also a new way of working. And this evolution started 15 years ago and is well underway in Europe. So that's why it's still new space for us, but no more for United States, I think.
Okay, good point. As you said, I believe for myself that there is no such thing as a perfect definition or normative definition for new space. So every single guy or girl has his own keywords to define it. So I have mine. First keyword obviously is commercial, as opposed to the early ages of space where everything was dominated by either defense or science objectives. Commercial space is something that is going up with new space. Also, it's not really new. If you look at Arianespace, probably, which is the first space startup ever, it was founded 4 decades ago, and 2/3 of its activity is commercial space. So commercial is not enough to define new space. Maybe you can add a second keyword with capital, as you have shown in your introduction slide. The fact that private equity and fundraising and so on are going to space activity is something also an highlight for new space since maybe the 2010 or something like that. This is probably a result from the overall economical situation in the worldwide, let's say, but also for an improved attractivity from the space sector, because we discovered we are, while moving forward, space is becoming more involved in downstream application, as you have highlighted, and we will talk about. And this is also why I believe fundraising and private equity is flowing down more towards the space sector. And last keyword, maybe it's speed. If you are in an innovation period, you have to be swift and to deliver innovation at an accelerated pace.
Yeah. So, well, if I try to synthesize for you what brought this new space and what brings all the innovation we see today in the sector, it's like the global economy, like more funding, more commercial applications, and well, also, I guess, some technical breakthrough that are possible today that were not possible before. Is that a good summary?
Yeah.
Yeah, it is. But before talking about technological breakthrough, you have to, again, it's my first keyword was commercial. You have to talk about what markets are being attractive to, and this is driving the technological innovation. So before technology, I think the fact that new markets are emerging where space is seen as a good enabler is the fact that is the main factor behind the new space wave. But this is a personal view.
And that's another question that just popped up in my mind. We didn't talk about this, but in terms of talent, like, is it easy to find talents in the space industry today? Like, how does it work in terms of training of people, and like to find talent to address all these new application and this new sector that is booming?
Do you want to answer, Jerome? Or I can say something. I think there are two talents. You know, you have the institutional talents, which are still sick as usual, and you have new actors, as I said, which create their own talents, and that you can have this new ecosystem of new talents, which was not completely inside the in fact, the institutional space ecosystem. So it's quite, as I said, a talent which is with birth, but outside the normal way of teaching and school, and so it's new people for me.
Okay, maybe what I can add, to answer very straight to your question, I don't see any difficulty to attract talent in the space business. I mean, there is a lot of passion and involvement in space activity, and every time you propose something that is related to space, it's appealing to the people, and maybe it's particular to Europe and the area we are working on. But there are a lot of talented engineers around that are ready to tackle the challenges we have in front of us. So I don't see a difficulty on that point. Maybe the only thing is that we are, as Christelle was hinting, we are in search for different talents than in the past. Not only a rocket science engineer, but people who can handle business case and who can have this kind of skills, also that are very familiar with digital and so on. So this is different talents than in the past, but we have them, no doubt.
That's great. And well, since we mentioned, like a lot of new business, a lot of companies entering the sector. Like preparing this event, I read some analysts talking about a consolidation of the launch vehicle ecosystem. So there are so many companies out there today that in the next couple of years, some experts expect that these companies are going to disappear because there's too much offer for compared to demand. So Jerome, since ArianeWorks has a big focus on launchers, I was curious to have your opinion on this topic.
Okay. Well, regarding consolidation, it's a little bit like yes and no. It depends on what you are looking at. It's a very different situation for big launchers and small ones. I mean, big launchers are also addressing public market, institutional markets, and usually small rockets are really driven by only commercial activity, and this is a very different situation. What is clear is that you have to look at the basic numbers behind and the market size and how it evolves. And I have to say, regretfully, the commercial market of space access is not really huge. It's about 2 billion for big rocket, and well, you may play with the numbers, but around 300 million for small rockets. So with 300 million for small rocket, if you look at there is more than 100 small rocket projects currently in development. It's too much. There are too many projects, so probably there will be a consolidation. But on the other hand, for big rockets, usually they are supported by other aspects than just pure market forces. Geopolitics. Every space power wants to have its own sovereign space access, and so on this side of the market, big ones, I don't see much consolidation happening. It's more like for the small market business. And maybe one last thing, when you look at the number of the space access market, people are pitching, okay, you will lower cost and it will the market will explode, as you said, or will increase. Regretfully, again, history shows that this market is not elastic or poorly elastic, meaning that decreasing the price does not trigger something big.
Yeah. So it's interesting to see the difference between these two typologies. But on top of all the launch vehicles, there are also a lot of new verticals being developed. And well, Christelle, I think you have you look at this a lot. So there's like communications, mining, space data. We talked about downstream and all the new applications. So can you tell us a bit more about the scope of all these new verticals that like appear today and are being developed?
Yes, I will say to summarize that the future of space for me is beyond space. And we can speak of space applications. We are increasing exponentially thanks to a growing number of satellites and more accessible data, as you said, with greater recurrence and precision. The upturn is taking place in a very favorable global context with the development of artificial intelligence and powerful algorithm, specific funding, as I said before, and international cooperation. So, for example, some application which are our favorite is mobility, with greater precision and integrity to benefit smart transport, for example, new forms of mobility, optimization of travel, reduction of CO2 emission, autonomous vehicles. And we have also another vertical, which is healthcare, which is not so easy to find the link, but for applications such e-health, epidemiology, or technical innovation for long distance. On the third one is environment. The idea is to use space technologies to optimize environment protection, agricultural also transformation, and ways of tackling climate change. So that's our favorite domains, in fact, for Connect by CNES, because we think that space is particularly efficient in terms of economic and social impact.
Well, talking about all these new applications, well, definitely the space is now more accessible thanks to the new technologies, the new ways of launching all this technology. So now we have this breakthrough of having reusable launch systems, and it's been really helpful in reducing the cost and allowing people to access space because it's cheaper. What breakthrough do you think what other challenge do you think we need to overcome to make space even more accessible? Is there like another big challenge that we're facing today?
You want me to start, Christelle? Or?
Yes. For you.
Okay, I won't start with talking about rocket, if you will, because this is going on both ends of the value chain of space. As Christelle was explaining, a good part, or the most part actually, of the space value chain is on the other end in downstream application, and on this, what would be a space more accessible or more easy to handle is to get the data easily available from space to here on Earth, where you have all the analytics and all the applications that you can develop on this. So the challenge of having all this data flow managed and flowing down to the right people or companies that can make business out of it is, to my point of view, as important as getting a low-cost rocket. So I come to that now. Of course, getting to space, launching to space is if you look again at the economical number, it's a large part of the capex, of the investment needed in any space-related business. So it's true that working on lowering the cost of access to space is the main way forward in innovation on rocketry. Reusable rockets is a contribute to lowering those costs, but not only. If you look also in to the manufacturing technology, switching from sophisticated prototyping like we do to industrial production using 3D printing or using 4.0 technology in rocket manufacturing also is a good lever also to lower the cost. So there is a number of things that you can think about to have this to make space more accessible. So again, on both sides, the rocket side, where it begins with a rocket launch, and on the other side, when you have to handle the data.
Do you want to add on that?
So it is in the other way. I don't really insist of data flow and big data, because of course I think we have you know, a boulevard to exploit of all of this. So, but for me, the real breakthrough we should achieve it's the propulsion, in fact, and the launcher propulsion, and that's why I like very much these startups that you will show with Atomos, which use a nuclear one, because I think we really need something very new in the propulsion, and for thinking of 100 years, I would say.
Yeah, we are a little bit stuck for years with a chemical propulsion. We need something new.
Yeah.
That's that's true. When you see all the logistics implied by the current propulsion that we use, it's exciting to think about what it could be with alternatives. Well, actually, I had another question to ask you. You know, space is something that makes people dream, and like you expect a lot, and it's really exciting. So I was wondering, what is the most exciting thing, like space-related thing, that you expect to witness over your lifetime? So is it to see people on Mars? Is it to go back to the moon? Like, what is like exciting for you?
So perhaps for me, it's very clear. The dream is to see in my lab men on Mars. I think so. Our friend Elon is working a lot on that, so I'm very. I should be very happy to see that in my life, because for me it's a synonym of the meaning of human exploration and technological breakthrough. If we reach to do that, it's fantastic.
What about you,
I pick a different one. In the 90s, about the same time I decided myself for a space career, the first exoplanets were discovered. Now there are counting more, 1,000, 4,000, something like that. And this is something space-related that goes beyond, far beyond the professional interest in space. It's, you know, as a human being, you have big question about life in the universe, and so this is the past. And now, if I look forward for an event that I would witness in my lifetime, now that we see exoplanet, having a proof or a trace of life elsewhere in the universe, maybe on Mars.
Yeah, you're right.
would be such amazing and such exciting.
Yeah, you're right.
Indeed. Well, I would like to open it up to questions from the audience, but while people like pose their questions, please don't be shy. I saw some questions about how to reach out to you, Christelle, and how to reach out to Connect by CNES. So we will share your contact information, and actually, if you can put your contact information in the chat later, it will be easier for people to connect with you.
Yeah.
And I think my colleague Romain Erny, which is our space expert, is also in the audience. So if you're interested in setting up your business in Paris and you're in the space industry, feel free to reach out to him, and it will provide all the information you need. Well,
perhaps I can just answer a little bit more for the question. So we have a website on Connect by CNES, so you can see more than I said very briefly. So connect by CNES.fr, I think, and so you can look at it. It's not we can help you. We have a CNES guy in Japan, also in Tokyo, from CNES, who can be a contact. And we are also linked with the ambassade of Japan in France. So there are a lot of eager to make some link with Japan and to facilitate the exchange between the startups in particular. So I will put my mail, no problem.
Perfect. There's like an interesting question from Karen asking, do you know the percentage of women in space fields? Well, we have the chance to have a lot of women today. So we have you, Christelle, and then we have some female CEO presenting their company. Do you see a lot of women in the fields today? And did you see like a jump, like an evolution, like in the past few years?
So it's really a very interesting question because, in fact, I don't see a real evolution because the problem, I think, is in the school, at school, in engineer school, and the percentage is still 10% for engineer women in engineer school. So it's very low, and it's the same than it was when I just and so 20 years ago, more than that. And so it's very sad. And but I think we have to do really all something to work against that. And so that's why I particularly be implicate in women in aerospace and all this association, because I think we have to speak more and to explain that it's perfectly easy to be a woman in space activities. I think it's it could be easier than to be a nurse, or so. There are a lot of other work which are not so easy. Mm-hmm. So, but the percentage, I will say today, in CNES, it's 30%, for example, but it's not all engineer. It's also, you have secretary assistant, and you have other work, job. So, but it's still space.
Maybe if I can add a word as a man on that one, we need to, need to do something. We need to do something. We need to be more proactive. I like, well, as you said, CNES is doing a lot, and half of the board of CNES is split between women and men, and this is a kind of
the high board, you know.
The high board, yeah. They share also the
high board in the middle level. It's not so. Yeah.
This is a kind of. It's a duty. I mean, we have to do something.
Yeah.
Well, a lot of people are sharing on the chat and the questions some initiatives and some events happening the next few weeks that can help for women to connect and do things together. Well, we had another questions regarding. Sorry, trying to retrieve that. So actually, you can see on the question tab that you can vote for the questions. So if you're interested in the questions, you can tap, and the audience can make them pop up. So we have Aurélien asking a question for you, Christelle. In terms of procurement, what the percentage of contract given to startups by CNES versus like large industrial players? Because, you know, like more partnerships are now happening between traditional players and startups or private players. So do you have an idea of the percentage?
Excuse me, the percentage of what exactly?
Percentage of contracts given to startups versus contracts given to large industrial players.
No, I don't have the exact percentage, but I can say it's quite low.
Yeah,
maybe I can help you on that one, Christelle. At least for the rocket part of CNES, we have KPI on that. So if I remember well, it was around 20%. So you have to look in either in number of contract or value, because usually you can go a lot of contract, but if it is only 10K contract, it's it's not bringing a lot to the new space industry. So depending on which indicator you are looking at, either value or number of contract, it goes between 10 and 20%.
Interesting. Well, thank you both. I think we'll move on to the startup presentations. to stay on track. Thank you very much for your insights and accepting my invitation. Please stay here for the second part with the startup presentations.
Okay, thank you. Thank you very much.
Thank you. So first, we have the startup Arkisys. So I'd like to invite David Barnhart, CEO and co-founder of the company, to join me to present the company. Hi, David. How are you? I think you're on mute right now. You just need to open your mic.
Got it. Yeah. Hey, good morning, good afternoon, good evening. Pleasure. Thanks very much for inviting me.
Well, thanks for being here. So I'll just set up the presentation, and then, well, I leave it up to you.
And then I can step through it. Is that right, or no?
I think you can. Yeah, you can try.
Okay, cool. Right. Yes, it works. Cool. Yeah. Okay. Thanks very much. All right.
Well, the floor is yours.
I appreciate it, and I'll stick to the 4 minutes. Welcome everybody. Really appreciate the opportunity to sort of talk about it. We are truly believing that the future of space is going to go beyond just sending up a single satellite to look back at the Earth. Instead, there's going to be a huge explosion of undiscovered markets that are going to come online by all kinds of creative and innovative people. So our job, and honest, is to create a new destination in space specifically to allow you to do that. So we're focusing on a number of things to get you there quickly till you can produce revenue. You don't have to be a rocket scientist to get up. We really are trying to make it very simple for you to focus on ideas and business. The intention is to allow anyone to get up who isn't necessarily within the space industry. And then the other thing that we're really working on hard is the construct of reuse and recycle. Nothing should be thrown away, especially because it's difficult to get into space. So we're specifically working on that. Our concept that we're using this to execute is called the port, and it follows very similar to the nomenclature that is used in nautical ports today. In particular, in this case, it's a technical and a business platform that is modular, that allows it to scale by definition, specifically to grow current and future markets. We describe a port in space as one or more of the port modules. What you see there in the hexagonal shape is a port module, and it's designed specifically to aggregate to itself and to other elements that go up to it. It's really a commercial platform. We really thought about this differently. This is not just some other thing that goes up, that floats around. It really is meant to simplify access into the space business for you all. We are going to make sure that we have scheduled deliveries from both FedEx on the ground as well as overseas, if you will. That is from ground to orbit within 90 days. We have the ability to accept any visiting vessels that come up to us and host payloads so that you guys can focus on your business specifically. We are also going to have technology available to build a satellite separately on board the port and release it. I mean, honestly, what we're really trying to do is to enable this next step in sort of the business ecosystem in space that we're all really excited about. We're going to do this really simply. Port services. We'll be able to onboard people on the ground before you ever build anything, and very simply execute through service model only. We're going to start with very simply, you're going to be able to lease some of the technologies that are on board the port. So you don't even have to launch anything before you can get into space to test ideas, concepts, and even potential code or technology. We then have the ability to host new payloads or new technologies. There's over 60 berth locations on board each port module. And as we grow the port with multiple modules, that'll increase even more. We have the ability to accept, to rendezvous with, to dock, and to berth visiting vessels, to onload, to offload, etc. We're also looking at specifically not just sort of Earth-focused technologies, but also this new burgeoning area of space-to-space activity. So business to business, if you will, within space. One of our first activities, besides just being able to host visiting vessels, is to build and lease a satellite that is custom from orbit at a much, much lower price. Again, this concept of reuse and aggregation is paramount in everything that we do. And then, of course, we are always looking to expand services significantly as we go forward. The first port, as we call it, is going to be in Leo in the spring of 2022, so it's coming up pretty quick. It is an ISS-compatible orbit. That's very strategic because most of the launch sites around the world are accessible to that orbit. It also means that we can leverage the rideshare and the opportunities that go up to within an arena of the ISS. So again, cost and fast transport is incredibly important to be able to get up. Of course, we are reaching out from the ground standpoint to all the small launch vehicles that are out there that are up and coming. We really believe that they're the ones that are going to provide fast resupply access, but we're still also talking to the large ones like SpaceX. And then to acknowledge and actually appreciate and help support those that are coming online, one of which you'll hopefully hear about here shortly. We're also looking at working with the OTV providers, or on-orbit transfer providers, that want to move things around in an orbit. So again, we're looking at this like a true nautical port where you get things on the land of the port and you things that come from the sea. So we're actually working with both of them. The really cool thing that we see is while we're grounded in pragmatic existing markets, in all honesty, the technologies that are opening up in robotic systems and modularity that are going on orbit, the ability to move things around orbits now will open up what we truly believe is undiscovered business and markets. We want to be there for that. We want to enable things that maybe haven't even been thought of today with a platform that has robotic capability to build, to dock, to add things to it, to release things. In all honesty, what we're really understanding is we're creating an orbital destination for new business growth. We recognize the expanding ecosystem that's occurring, and it's fascinating. It's moving really quickly. You're going to hear about some of them today. There's many others that have already been talked about. But in our case, we really want to be a nexus to support all of these and expand even further. So orbits, in this case, are really locations that you can create a port. Our goal is that you ought to be able to create these things anywhere and therefore open up opportunities for business in any particular orbit as it's described, whether it's around the Earth or up and coming to the moon or even going on to Mars. Really appreciate it. We have a video on the website. You guys are welcome to go see. It's sort of a little bit of fun, but it actually explains what we're doing. And we actually would love to have all of you guys come on board. So thanks very much.
Thank you, David, for the presentation. So while people can post their questions on the question tab, yeah, I wanted to tell people, please go see the video made by Arkisys. Like, the video is really great. I really love the energy in it, so it's really a must-see. I had a question regarding the lifespan of the port. Like, do you have any information to share regarding like how long you plan on being able to use the ports, and like, yeah, like what is the timeline and how do you see things related to that?
No, I appreciate the question. So again, we're thinking differently about this, whereas typically in the past, almost all space systems are designed from the very beginning to eventually die. Our view is that everything that we've done from a technical standpoint, as well as logistics standpoint on what we describe as a port module, is replaceable and repairable. So there is no reason why a port that is made up of one or more of these modules cannot stay on orbit for decades at a time, because we're building in specifically the ability to add, take away, down mass, bring new things in, and replace as needed specifically. So our goal is we want to be up there in any one of these orbits as a destination for anyone to get to, and hopefully have stepping stones, you know, is from Leo all the way out, like I said, to the moon or even beyond.
Mm-hmm. Well, we have another question regarding COVID and how it impacted your business, because well, you mentioned a pretty close, like a pretty tight time frame, talking about launching in 2022. Has the pandemic affected your plans and the timeline that you had?
Yeah, it is a valid and a realistic question. No issue. We have, I think, but like all of us here, and as we're doing right now, we have taken advantage to the maximum extent that we could for remote operations. When we started over a year ago, it really in earnest with our very first contract, it was just about the exact same time. So we had one in-person meeting, and the rest of it through all the design phase has been remote. The companies that we specifically work with and the facility that we're putting together, we have taken great pains to make sure that we do as much as possible in terms of protecting the individuals. Doing things remotely, which may include even not being in the same rooms with each other, even if you're in the same facility. There are many things in terms of hardware that at some point you have to take that step to actually put things together. This is something that's happened through the entire aerospace industry while this pandemic is occurring. We've actually had really good conversations with Lockheed Martin and Boeing and Ball Aerospace as an example, sharing ideas and best practices for how do workers put on the appropriate PPE and what processes that occur before they go onto an integration floor. So while yes, there's no question it has some level of impact, we have taken great pains to try to mitigate that as much as possible to maintain forward momentum.
Awesome. Well, thank you very much, Dave. We have to move on. Thank you again for joining us. And well, same as everyone, feel free to share your contact information so people can reach out to you if they're interested in knowing more.
Will do. Thanks.
Thank you. Next up, we have Atomos that we mentioned earlier with Christelle. So I'd like to invite Vanessa Clark, CEO and co-founder of Atomos, to join me.
Hello.
How are you? Good to see you.
Doing well. Thank you for the invitation to speak.
Of course. Well, I first heard about Atomos. I think you presented at Hello Tomorrow in Paris. And I've seen a couple of videos and read a few articles. So very excited to have you. So, well, the floor is yours.
Okay, well, great. Well, like to also thank Jerome and Christelle, who mentioned our company during the fireside chat. So we are indeed an in-space transportation company, but as I go through the presentation, you'll also see that we are a space nuclear technology, and we're dedicated to the realization of those technologies. So I'll start with a background as to why our business is so important. So rockets were created primarily for military use, designed for a single satellite with little consideration for cost. And now, 70 years on, we're still using the same systems, but now we're putting thousands of satellites into space. Because of the limits of engineering, single-use expensive rockets are often underused. And when a satellite operator has to buy an entire $90 million rocket for launch, wasted capacity means wasting millions of dollars. Additionally, launching satellites one or two at a time means that launch becomes a schedule bottleneck. Wait times can exceed years. It is expensive. It's inefficient. It's like flying passengers one at a time in a single-use Boeing 737. It does not need to be that way. At Atomos, we are building and operating space tugs. These are orbital transfer vehicles that are the connecting flights in space. Rockets no longer need to go all the way to a specific orbit for a specific satellite. With space tugs, rockets can launch satellites to a single drop-off point, and we'll take them from there. Let's dive into this. So Atomos' customers, who are predominantly telecommunications providers, launch on a rocket to a low orbit, like they do today. But more satellites going to different destinations can ride share. Something that isn't really done today. our space tug or orbital transfer vehicle would rendezvous with them in space, transfer them to their final orbit before returning for more satellites. Now, this model does three things. It lowers the cost to get satellites on orbit. It reduces the time to get satellites in space. And it means that rockets can access more orbits. And this is all made possible by our electric propulsion technologies. So our electric engines are 10 times more efficient than traditional combustion engines. And with our initial vehicles powered by lightweight solar arrays, but growing into small space-based fission power systems, we can do really efficient heavy mass transfers, and we can scale up to human cargo and crew missions to asteroids and to Mars. We're sending our first orbital transfer vehicle to space in 2022. With our incremental approach and initial use of off-the-shelf components, our costs are also a fraction of those of a rocket startup to get up and running. We're launching next year, and we're serving customers and immediately providing value. Commercial space tugs are inevitable. One reason for this is that ground-based communications will simply be insufficient for our future data needs. As was mentioned in the fireside chat, more satellites are going to be launched in the next 10 years than in all of human history. And as a company, we've spoken to the leading operators behind this growth, who collectively operate hundreds of satellites in orbit today and are launching thousands more in the next few years. And it was unanimous. They want lower costs, more flexibility to get to their operational orbits. They need a solution like orbital transfer vehicles and our space tugs to exist. We don't just need updated rocket technologies or new small launches to solve the problems of the new space economy. We need new ideas and pioneers. Thank you.
Thank you very much, Vanessa, for the presentation. There's a question already from Adrian asking, well, you mentioned you wanted to launch next year. How do you plan to launch the thugs? And how do you plan on, like, is there any assembly related to like the fact you put the thugs in orbit?
So our launch next year is actually a launch of 2 vehicles. They are very small, so they're ESPA class, so 200 kilograms mass, and they're launching as secondary payloads on a launch. We have no on-orbit assembly required. And so even the larger vehicle that uses either a very high-power solar array or a small fission-based system can be launched integrated on a single launch vehicle.
And then regarding servicing of the thugs, like how do you plan on making this
What do you mean by servicing? Do you mean refueling? Do you mean how we rendezvous with our own clients? What do you specifically mean?
Yes, for refueling, for maintenance, like is there anything like that that you have to work on? And I mean, you have to think of?
So our main maintenance activity is refueling. And so for this first generation of vehicles, the solar electric power spacecraft you can see here, the Quack, we actually refuel it by launching propellant with our customers. So we have a custom designed launch dispenser that also has a propellant bay. And so this dispenser and refueling tanker is inserted into a low orbit. Quack is capable of autonomous rendezvous. And so with the, you can see on this end is our docking and refueling interface. So there are 2 refueling valves on this face as well. So we can go up and dock without use of our robotic systems. And we can refuel through either of those 2 ports. Then we still have the customers attached to the dispenser refueling tanker. So we can then perform a commercial mission where we deploy those customers into an appropriate orbit. In terms of other maintenance activities, there are missions where we would have degraded life of our power systems. So for example, if we're doing a low Earth orbit to geostationary transfer with a solar electric vehicle, the lifetime of those solar arrays is severely eroded. And so we would then use our own robotic systems. We have a modular system where we would swap out the solar arrays, but we really don't foresee any other maintenance.
All right, thank you for your answers. I don't see more questions. Feel free, everyone, to, yes, we just got a new question. Yes, so we have Aurelia asking us, could you take us through the propulsion system of Quack?
So Quack uses ammonia propellant for both attitude control systems and electric propulsion. So the attitude control system is just a cold gas thruster, has pretty good specific impulse. We use these because Quack needs to be pretty agile. It does perform rendezvous and docking in some pretty perturbed environments, as low as 250 or 275 kilometers. So probably aware that that's a very drag environment. We do need a lot of thrust. The main orbital transfer propulsion system on Quack is a resistor-jet thruster that also uses ammonia. Moving away to larger vehicles, resistor-jet isn't a great solution because we are limited with specific impulse. So we are going to the plasma engines when we increase power levels beyond Quack.
Thank you. Well, thank you very much, Vanessa. We're going to move on to the next company. Thank you so much for joining us today and presenting Atomos.
All right, thank you.
Thank you. Next up, we have Apollo Fusion, which is, well, also about propulsion. So I'd like to invite Mike Cassidy, CEO of Apollo Fusion, to join me. Hi, Mike. How are you?
Good, Melvin. Thank you very much for inviting me.
My pleasure. So let me just set up the presentation. And yes. All right, here we go.
Okay. And thanks, everyone, for coming to this session. I think it's really exciting. I've really enjoyed all of the previous speakers' presentations as well. So I'm the CEO of Apollo Fusion. We make a type of ion thruster. It's called a Hall thruster, type of electric propulsion for satellites. And in the 4 minutes, I'm just going to talk a little bit about some recent progress we've made. We've landed 4 deals over the last 4 months or so. The first one was a US Air Force intelligence satellite. Next one is we're providing the propulsion for Saturn Satellite Network's small geosynchronous satellites. The third one is a company called Spaceflight Inc. They do space tugs called the Sherpa from low Earth orbit up to higher orbits. And the one we just announced this week is York has selected us for our LEO constellation. We have some great members on our team. One of our VPs led propulsion at SSL and OneWeb. One of the lead electronics designers of Rocket Lab's Photon, and also we have a ISO quality auditor from General Electric. And the team members, sort of their history before they came to Apollo, it's sort of a lot of experience. They've designed and built hardware that's flying on over 1,000 satellites in orbit today. We have people from SpaceX, Aerojet, OneWeb, SSL, Rocket Labs, a bunch of companies. We raised about $25 million in funding, and we have 4 vacuum chambers on our site. You can see some of these pictures here. And we have a high volume aerospace and defense manufacturing partner that does all of our flight hardware. Here's just a picture of some of the programs we're working on. Here's the Sherpa space tug. Here's Saturn Satellite Network's geosynchronous satellite. This is twin ion thrusters. So we call it our TIE fighter experiment. This is for one of our US Air Force satellites. And at a high level, we have 2 types of Hall thruster. ACE Apollo Constellation engine is our 400-watt version. We use xenon and krypton, and typically you could do a kilometer a second or so delta V with a 150 kilogram satellite with this one. And then Ace Max on the right is a 1400-watt thruster. That has an ISP of about 1800 seconds or so. It's magnetically shielded. That means you can do a very, very long total impulse through it. You can do 1.5 or 2 meganewton seconds of total impulse. The magnetic shielding prevents the ceramic from getting eroded. And a lot of technology has gone into this. It's center-mounted cathode, heaterless, instant start, no moving parts. That's just some of the technology that goes into our thruster. And the magnetic shielding, you can see on the left is a picture where you can see the plasma basically erodes the ceramic. But on the right, if you do magnetic shielding correctly, the magnetic shielding pulls the plasma away from the ceramic. So that's it. And we're at apollofusion.com is our website, and we'd certainly be interested if anyone wants to talk to us about thrusters. Thank you very much.
Thank you, Mike, for the presentation. There was one question regarding the funding, since you said you've been raising 25 million. How do you plan on using the funds, and what is the timeline for the next few years for Apollo Fusion?
Well, a lot of those giant vacuum chambers I showed, they end up costing a little bit of money, and doing these qualification tests. Xenon is expensive too, so it takes money to for the xenon. And the team. We're in Silicon Valley, so our salary rate is it's a big chunk of our finances is for salaries. And the future, we're working on quite a few proposals right now. I think about 15 different proposals. We have we have over 20 thrusters now with the deals we have, and if those go to their follow-on projects, that would be 200 thrusters. And the proposal we have out right now is 2,000 thrusters. We don't know how many of those will win, but if we win, half of them or a quarter of them, then it'll be a great year for us. So yeah.
That's awesome.
Yeah.
And so you're based in Silicon Valley. Do you have your manufacturing also here in California?
Yes, and that's been a real strong suit for us. We're kind of a scrappy, rough and tumble Silicon Valley, fast-moving startup. I agree with Jerome's points earlier that speed is really, really part of the new space. But right down the road from us, we have our manufacturing partner that does all of our flight hardware, and they are ISO 9001, AS 9100. They make, they've been making hardware for years for Raytheon and for Northrop Grumman. So our customers love that. They love the speed of our lab and our startup, but they love that our flight hardware is made by an ISO 9001 experienced aerospace manufacturer.
Mm-hmm. Well, if you don't have any more questions.
Okay, thank you very much, Melvin. I think this program is great, and I think what you guys are doing is awesome. Thank you for letting me be part of it.
Thank you so much, Mike.
Yeah.
See you soon. Well, so moving on to the next company, we have Kelly Larson, CEO of Aquarian Space. I'd like to invite you to join me, Kelly.
Hello.
Hi.
Hi. Thanks so much for inviting me to be here today.
So glad to have you. So here is the presentation, and well, I'll leave it on to you.
Fantastic. So we are here today. So again, I'm Kelly, and we're Aquarian Space, and we're here today to talk about networking the solar system. So I remember, I'm going to date myself here. I remember when phones had cords and they were attached to walls. So maybe some of you remember that. I even remember when I was a kid, my grandma had something that was called a party line. And what that meant is if I was at her house, I might pick up the phone on the wall and hear the neighbor having a conversation. So she'd have to wait till that neighbor got done talking, or I would, and then hang up the phone and wait, and then I could make a call. So communication on Earth has come a long way in the last decades. Cell phone, telephone communication has come a long way. Even space communication in the Earth region has come a long way. You noticed earlier when they did that market map and they listed all these companies doing space communication, amazing things are happening. However, most of that is happening in the Earth local region. And what we're here to talk about is deep space communication, which is more about Mars to Earth, Moon to Mars, things like that. And that communication has hardly changed in the last 60 years. Very small technology changes. And my co-founder, let me figure out this slide change. Here we go. Oh, there we go. My co-founder, Michael Hackman, years ago noticed this when he was working on these big missions, that people would make a change over at, say at something at Jupiter. They would make a small change in their satellite, and then they would wait for the data to find out if that worked. And they would sometimes drive to the NASA antenna sites to get the data rather than waiting more days or weeks for the data. Currently, 70%, so he started looking more, what is going on with deep space data? Why do we have to wait so long to find out, to get this data that we're sending the satellite up there to get? And he found out that 70% of the hours were contested for deep space data. So what that means is that, kind of like the party line at my grandma's house, somebody would be sending data and somebody else would be arguing and saying, actually, I want access to this, I need it right now. And there's a lot of demand. And this is just from data from 2010 to 2018. During that same time, the top 50% of the antenna access hours went to 25 customers. What that means is that 75% of the customers that were important enough to get onto NASA's priority list, 75% of them were only getting little scraps of data. They were all getting 4% or less of the time. So those 75% of customers were underserved, and there are plenty of customers out there that can't even get into that. Now, what's amazing is that the number of customers flying in lunar and deep space is about to triple. At the moon alone, so we're starting at the moon alone has a $3.4 billion opportunity here just in the next decade. It is a huge demand that's happening right now, and we all know this is coming, and we all know that this needs to happen. And Aquarian is in a unique position to lead this charge. And our solution is fairly straightforward. We are stringing satellites through the solar system like cell phone towers. Relay satellites so that our customers can go from the moon, initially it'll be at the moon, can go from the moon to our relay, which will be local, down to Earth. So we're offering faster delivery and more cost-effective solutions. There will be no scheduling. Our customers will not have to schedule. They won't have to compete for priority. They're going to have high-speed data rate upload, 24/7 access from the moon. Our customers will be able to send more data to the Earth, and they don't have to change anything on their spacecraft to interact with our system. So we are in a great place right now as a company. We have our technical strategy and a powerful technical team ready to go. We will soon be making some announcements about that. We have our satellite builder agreement is in place. Our customers are engaged, and our revenue projected just for 2023 to 2029 is over over $1 billion. So right now we're raising a small pre-seed round in the next few weeks to secure our team, to get a few LOIs from our customers, and to finalize our payload builder agreement. So this is a really interesting time to jump in with Aquarian. We are definitely open to investors and strategic partner conversations, and it's a pleasure to be here, and it's a pleasure to be on this emerging industry at this really incredible time. And you can reach me. It looks like I missed a slide here, but I will put my email in the chat, and I'm also on LinkedIn. So thank you.
Thank you, Kelly. Yeah, we'll share the your contact information with everyone, and I'm sure some people might be able to might be interested in knowing more about the fundraising and might be able to help you. So that's great. So we have a first question from Mark asking how you can make sure that the relays are always available for to transmit information, depending on like the different orbits, depending on like all the obstacles you might have, since you're, well, maybe not for the moon, but since you're projecting further in the solar system, like how do you synchronize all of this?
This is a good question. There are pieces of that I won't get into specifically. Some of this might get into trade secret territory, but what I can tell you is that you're going to have great access. We'll have more than 99% of the time, our customers on and around the moon will be able to see us. We're launching our first satellite in 2023. That'll be at the moon. Our second one at the moon will be in 2025. So those two satellites, our customers will be able to see us and send data 24/7. And then we have similar plans in other places in the solar system. Mars obviously will be soon to follow.
Exciting. And then a question regarding the pricing and the business model. How will you charge companies to be able to use your network for their communications?
Right. Initially, we're going to be doing the same basic way it's been done for decades, which is by the hour. We're definitely looking at, what we realize is right now our customers most of our customers can't even send the amount of data that we can receive and send for them because they're designing to the current system. So they're only going to send, so many megabytes at a time. So we can receive all that, no problem. But as our customers start to build to greater data capacities and we're able to actually fill up our bandwidth capacity more, then we'll be looking at a baseline amount of data per hour and then the ability to pay more for additional data. But initially it's going to be by the hour. We'll have competitive rates with the DSN, which is the current standard. And the DSN is doing a great job and working amazingly well. They're just very full and they're only planning on serving the moon for not much longer. So we're there to help everybody who wants to be at the moon and then other places later.
Great. Well, I think that's it. Someone, I think, was just not very clear with the beginning of the presentation and the exact problem you're addressing. So I'll let you maybe answer on the chat, or if you want to synthesize in one sentence, just to wrap up.
Essentially, the problem is that all communications from deep space are currently going direct to Earth, and there aren't enough antennas or capacity in those antennas to receive all of them. So we're going to relay, and we can receive a whole bunch of them at once, and then we'll relay them down. Hopefully that helps, and I can write more in the chat. Thank you.
I think so. Even for me, I'm not an expert in the field. That's very clear. That's very helpful.
Okay, good.
Thank you so much, Kelly. So great to have you. And well, you shared your contacts already, and I invite everyone to reach out to you if they have more questions.
Thank you so much.
Thank you. And then last but not least, we talked about Earth observation. We're going to have our last company presenting, Australia. So I'd like to invite Brendan Richardson, CEO and co-founder of the company, to join me on stage to present. Hi, Brendan.
Hi, Melvin.
So let me set up the slides. Here you go. Great to have you. Well, I'll pass it on to you. The floor is yours.
Thanks so much. And thanks to Choose Paris Region for having me. It's a pleasure to be here. I'm the CEO and a co-founder of Australia. We are well downstream of the colleagues that just presented. We're not hardware, we're software, and we're working in the Earth observation space. The quick snapshot of us is we have built the first integrated software as a service platform for global scale geospatial analytics. Jerome mentioned the need to more easily and more affordably access the data that's being generated by all these Earth observation satellites on orbit. We do that. We do that by putting tools and data and the know-how directly into the hands of the customers, with a very strong focus on commercial customers rather than government customers. When we do this, it generally results in up to a 90% reduction in the cost and the complexity of building and putting into production EO applications. We've been around for 4 years. It's a small team. We're 18 full-time engineers, data scientists, remote sensing experts, and high-performance cloud computing experts. We're backed by private investors and one very large international foundation focused on climate change, headquartered in the US. And what we really have built is 3 integrated products as a platform: Earth on Demand, Earth AI Notebooks, and Earth AI Workflow. Earth on Demand is the search and discovery piece of the platform. It allows customers to easily find all of the available satellite imagery over an area of interest and a time of interest. We're currently cataloging more than 30 million scenes and 15 petabytes of publicly available data. We also provide access to paid data from our data partners, including Maxar, Skywatch, and others. And that also includes a pretty significant discount for NGOs and nonprofits working on big problems like climate change, land use, et cetera. We also have Earth AI Notebooks, our analytics engine and environment, the Jupyter Notebook, that allows users to apply advanced machine learning and AI analysis to this data seamlessly. It's built on an open source core called raster frames that we have built so that vendors don't, particularly government vendors or government customers, aren't locked in to Australia. And we have Earth AI Workflow, which is a low code, no code environment that lays over the top of Earth AI Notebooks and allows folks to do this without Python knowledge. As I mentioned, we have key data partnerships, all the public providers. We have reseller agreements and partnerships with Maxar, Skywatch, and others, Capella, and more coming all the time. A couple representative customers and applications. We have a global energy company as a customer. What you're looking at there is a machine vision model that we built on behalf of this customer that detects utility scale solar farms using Sentinel-2 10-meter imagery, free, publicly available. When we score that model on places where that information is not readily available, we can do it cost effectively. What you're looking at is all utility scale solar farms detected by a computer vision model in China, mainland China. We scored it on 18.5 million square miles in roughly 14 hours in our cloud platform at a direct compute cost of about $650. Develop that information by hand or traditional techniques would be a multiple order of magnitude greater cost than that. We work with hedge funds through consultants and directly with hedge funds. We've developed a patent pending algorithm to count cars. Everybody uses counting cars as a particular application for EO data. We do it with free coarse 10-meter Sentinel data using smart algorithms and software. You don't have to buy the expensive 30-centimeter data. It reduces the cost of delivering that application by more than 90%. We're now applying this to other hard-to-see but important to count objects, wind turbines, shipping containers, utility substations, et cetera. Our oldest and one of our largest customers is the Nature Conservancy. We do have a big focus on enabling NGOs and nonprofits to use this data affordably. The Nature Conservancy and its 1,500 geospatial analysts use our platform for all types of different applications. We're also a central purchasing repository for Nature Conservancy chapters to buy the paid data from Maxar and our other partners at a significant discount. We make money 3 ways. We have a SaaS model, so a recurring monthly subscription to one or more of our platforms. We develop our own proprietary information and data products We are a reseller of imagery. We call ourselves pixel agnostic, so we work with as many private providers as we can. And we also do services and integration for customers that don't want to bring that expertise in-house. Our executive team, this isn't our first rodeo. We've been working on large scalable machine learning and AI systems for commercial customers and government customers collectively for more than 200 years. This is our first joint foray into the EO space, but our background is I think, directly relevant. And we've made some real progress in lowering the cost and lowering the complexity of accessing, analyzing, and making sense and insight out of EO data for our customers, and continue to do so. Thank you very much. I'd love to talk to anybody that has an interest in EO data.
Thank you, Brandon. Thank you for the presentation. Well, so we have a first question from Yuhei saying that it's a big issue for them and that most of the companies don't know what satellite data can do for them. How do you do with this situation? How do you convince people of the potential of space data, and how do you like make them understand everything they can do with it?
Yeah, no, I've been living this question for 4 years. It's a great question. It's a spectrum. You know, I think the fascination with EO data has been, you know, with us for a decade, and yet there aren't really any killer apps that you could point to. Everybody points at car counting, you know, in part to figure out what quarterly sales are going to do, but nobody really uses that application, and the reason is because it's too expensive. And so, what we find is, say 10 to 20% of the customers that we talk to know what they want to do with EO data. Maybe 60 to 70% are unsure but intrigued. And with them, we spend quite a bit of time demonstrating what we have done in the past and brainstorming on some applications where EO data can be truly transformative for them, particularly around in an era of COVID where they can't send people on location or put feet on the ground. And then the last 10% are really just kind of curious and want to look at imagery and figure out if they can find their cat that's missing or look at the roof of their house. It really is sort of a spectrum of hand-holding to a certain degree customers that are curious, but enabling and putting the tools and some of the know-how into their hands and giving them access to the data. And then those customers figure it out for themselves pretty quickly. You know, a smart data scientist can do this in a very rapid period of time, given the right tools and the data, and that's what we do.
Thank you for this answer. We have another question. I think we have time for one last question. Do you provide other sources of data, like SAR, open source civilian data, as well as data fusion and collaboration capabilities on your platform?
We do. We do provide SAR through our partner Capella, as well as Sentinel. And you can import your own, we can bring your own data into the platform quite easily. So we do host a lot of customer geospatial data, georeference data that is fused with the satellite imagery, and all of that capability is embedded in the platform. The answer is yes, all caps.
Great. Well, we have to stop here, unfortunately, but thank you so much for the great presentation, Brandon. Great to have you.
Thanks so much for the opportunity.
Of course. So yeah, I just wanted to say thank you again to all the presenters and for everyone who's here today. I would just like to share our next event with you. So as I mentioned in the introduction, we organize events on a monthly basis. So you have our program here for 2021. They're not all public, but the next public one that you can join online is Personalized Health on March 17th. And if you need some more information, you can reach out here. Here's my contact information. And well, I mentioned earlier Arkisys video. I would like to share it with you guys and end on this. I think it's a pretty great video, so I'll let you. I'll finish on that. Thank you again, everyone, and have a great rest of the day.
Imagine a future where one day you can transport, host, and operate new scientific and commercial experiments in less than 90 days.
We already do that.
Oh, okay then. Well, imagine one day in the future where you can create a unique satellite or spacecraft on orbit in under 90 days from start.
Excuse me. We already do that.
Oh, right. Okay. Well, imagine one day in the future where you could host a visiting vessel for servicing existing satellites for repairs or performance upgrades.
We're already doing that.
Seriously?
Seriously.
Right. Oh, okay. Imagine a future where you could aggregate a large platform that can be assembled in LEO and transferred to a different orbit.
Sorry, but we're doing that.
Right. Okay. Well then, imagine a future where multiple platforms
We're already doing that.
Arkisys. Imagine what we can do for you.
When I was a kid, I always dreamed about space. I loved watching the sky during the night. And I've always been fascinated by all the space explorations.
And I wanted to be an astronaut too. The space industry is really transforming quickly. And now we have much more satellites, miniaturized, and they operate in constellations. And this gives new activities and new markets for the space industry.
This is a fast-moving, dynamic market. Everyone heard about new space. It's all about making satellite business faster, cheaper, and much more accessible in terms of cost.
So TrustMe is a deep tech company in the space industry, and we provide new innovative propulsion systems for next generation satellites. We have 12 different nationalities.
Airbus is an international company. We are providing equipment for spacecraft, for satellites. I really enjoy working with people from other countries, with other backgrounds. We have exchanges, for example, with Centrale Supélec, and people come here to do their internships or their thesis.
At the Space Center, there are 4 nanosatellite missions on which we are working. There are about 80 students dispatched on all those subjects. On the mission ESIS, there is a partnership with NASA. We have the chance to work not only with French people, but more international people.
And it's very important to have this big mix between real big companies, startups, and also the research infrastructure. France is a great country to live in, and it's in the center of Europe, so it's a perfect place to be.